Hello, tech enthusiast. Our mission to build a neural network that can predict. In today's video, we will be exploring a high-level concept in machine learning. We will be staying on the surface of this vast field, providing a simplified understanding of one of its foundational principles. I will break down the complex concepts into pieces, guiding you through each step of the process. How a neural network works. A simple neural network includes an input layer, an output layer, and in between a hidden layer. The layers are connected by nodes, and this connection forms a network. The neural network is interconnected nodes, a combination of input layer, hidden layer, and output layer in simple terms. This is the code for today. I uploaded the code on the GitHub. This code might look intruding, right? Before we dive into the code, let us take a moment to understand it through visualization. So, the starting point of the neural network is input. Input can be of various types. It can be text, it can be image. Each text can be broken into the words, and each words has a predefined array. Like AMD has its specific and own unique array. This is an image, and if we broke an image into the pixels, if we say pixel as p, the pixel 0, pixel 1, pixel 2, RGB values, this is the kind of RGB values. It's a quick visualization how does an image is stored in an array, and this pixel 0, pixel 1, pixel 2 are stored into the array, and this array now represents this picture. So simply we converted an image into an array, but this array is not an independent array, it represents this image itself. So the single pixel containing the value of RGBs will store each pixels in an array where each pixel is an element in an array. Now this array becomes our input array, this array represents the image itself. And coming back here, convert it into the where storage, yes, internet input array, and already defined weights are calculated. So weights, a weight is a numerical value assigned to each input feature. These are typically set of random or initialized to small values. Like to sum up, weights are unique values which are connected with the input somehow, and this creates a new array which we call a tensor array. Tensor array is basically a multi-dimensional array which holds a numeric data. So for now, then input is converted into a multi-dimensional array which holds the numeric data. The input can be anything, as I said before. And to visualize till now, we have made a tensor array. This is the type of tensor array, each inputs, and these inputs are then sent to a hidden layer, and this hidden layer calculates on basis of so many things, and it gives an output layer and predicted output layer. And this is the inputs that we feed. In our case, it's a tensor array with the numeric values, and this is the weights, uniquely defined weights, and this is the relationship, and this is the hidden layer. This hidden layer is then goes into an activation function. This activation function gives an output. So in short, it's something like this: input neuron, weights, and then hidden neuron, weights, and then output neuron. And the hidden layer is based on the model we have selected. In our case, it's a selection model, and also the number of neurons. In our case, it's 10 neurons in the hidden layer, and output layer it's a 1 neuron. So basically, this is the 10. These are the neurons. In our case, it's the 10 neurons. In our case, it's the 1 output neuron. So then we compile our model. The compilation is based on the optimizer we selected and the specific loss function. To explain them, the next step is compiling a model. And we select an optimizer as Adam, and the loss function has the mean squared error. So they are basically responsible for the predicting accuracy, and this is the visualization for that. We use the Adam optimizer. Optimizer does a simple things. It optimizes the predictions and less and decreases the losses, and the less decreased loss we have, the more predicted or more accurate value we get. So the optimizer makes the losses less, so our prediction of the model or our accuracy to the model increases. So less the losses, more accurate the model is. And then we fine tune. Like this whole process goes on, and it stops until the minimum accuracy, the minimum losses, and the maximum accuracy is found. And then if we add any other inputs other than the inputs we provide in the starting, it will predict the output for the new. So let us dive into the code. First of all, we will import the libraries, the required libraries such as NumPy and Matplotlib and TensorFlow. NumPy is used for the computational, Matplotlib is used for the data visualization, and TensorFlow is used for building up the neural network model. And now the sample data generation. This involves creating an input feature X and corresponding target Y. So to train the model, we use X. X represents the independent variable which is used during the training, and Y represents the dependent variable which we will use for the prediction. So in simple terms, X is used for the training the model, and Y is used to predict the output from the model. This is the input for prediction, and this is the initial input for training the model. Yeah. And now the neural network model building. This is the TensorFlow sequential model. and we construct a neural network model. The model consists of layers, including a hidden layer with 10 neurons. Each neuron applies an activation functions ReLU, which is rectified linear unit, which helps the model uncover the complex pattern in the data. The output layer has a single neuron providing the predicted value, and now let us compile the model. Compilation of the model involves configuring it for training by specifying optimizers, as we discussed before, and loss function, which is mean squared error. The optimizer adjusts the weight of the neural network during the training to minimize the losses, as we discussed. And now we are proceeding towards training the model. This line, during the training, the model learns from the sample data by iterating, adjusting its parameters, weights to minimize the losses. The training process involves running the model through multiple iteration called epoch. In our case, epoch is set to 50, so the iterations will be 50. The batch size determines the number of sample proceeded before updating the model parameters. And as we use y as an input to predict, we will be plotting it. This is simply the data visualization. We are plotting it in this format. So in initial stages, our losses are high, so our accuracy is low. As we proceed training model, the accuracy increased and losses becomes less. This is the output for losses reducing. And once the training is complete, it's a prediction time. We will use our trained model to predict the output value for test data points. Then we will visualize both the original data and the modified prediction to see how well it fares. And this is the original data versus the prediction data graph. So, and this is a graph that shows the losses has reduced as we iterate over the data sets. So this graph means that the accuracy is increased by decreasing the losses. For better understanding, we will see the hands-on practical applications. Here I provided an image of a cat, and the prediction is made up of the cat type and which class it belongs. So it predicted 48% to be an Egyptian cat and 21% tiger cat. And how does these predictions are made? By just a simple image. Let us see the code behind it. As we saw before, the NumPy is for computation and Matplotlib for data visualization, these libraries, and we are importing a MobileNet v2 library, which is used for deep learning task. Loading the pre-trained model. The pre-trained model MobileNet v2 model trained on a ImageNet dataset is loaded. This model is capable for classifying image into thousands of categories. A function preprocesses the input image to fit the required input size, 224 to 224 pixels, and preprocesses it according to the MobileNet v2 model requirements. Predict the class. Another function is defined to predict the class of the input image using the loaded library, which is MobileNet v2 model. It returns the top 3 predictions along with their probabilities. Next step, we download the image. It's a simple URL that the image is stored at, and we download this image through the command line. And the predictions. The image is passed through a prediction image class function to optimize prediction. The top 3 predicted label along with their confidence score are printed. Finally, the sample image is displayed along with the predicted labels through the libraries of the data visualization. You might wonder we don't use any optimizations or any training sets in it. So it is because we are using a direct model which is already pre-trained. It has the accuracies and already defined in various things and various classes is distributed. So it's simply using such a pre-trained model, and we're feeding our input, our image, and it gives us the output. So yeah, this is the overall understanding how does a neural network is formed, or how does we can use other neural network or pre-trained model to find the output or to predict the value or to predict the input that are based on some specific classes.